Hey everybody, in this video I'm going to go over systems of inequalities. The important thing to go over with inequalities is how the line is graphed and how it's shaded, because inequalities mean it's not equals to. So system of inequalities work a little bit differently than systems of equations, and so that's because you have these shading rules right here and then these graphing rules with the lines. So you know that if you have a strictly less than or strictly greater than, you're going to have a dashed line, because dashed line represents something that you cannot touch. Because if you were to put a dot right on that line, let's just say it would be saying something like 4 is less than 4. Well, 4 can't be less than itself. But the solid line represents something you can touch, because 4 can be less than or equals to 4 because of that or equals to option. The next thing to review is the shading. Just remember, if you have less than signs, it's shading down because it's going less than that. If you have greater than signs, it's going up because you're shading greater than. So if you are graphing these, you're going to have to solve each for y, and in doing so, you might end up dividing by a negative number. So that's going to flip the inequality sign. Okay, so just don't forget to do that. So this first one, everything's equal to y, okay? So, or in y equals form, I guess. So the first one, I have a slope of 5. I have a y-intercept of 3. And remember, my slope is going to be 5 over 1, okay? And that's going to be a dashed line, and it's going to shade up, okay? So let's go graph that, starting at 3 and going up 5 over 1, dashed line shading up. So here's my graph. The important thing to note is the shading up. See how the line's very diagonal? Like, sometimes it can be difficult to determine whether to shade up or down. Which way is up or which way is down. Just imagine that line falling down. So if that line were to fall down, it'd fall to the right. So that means the shaded area is going to push it down if it's on top of it. So that's just something to keep in mind. It might help. The second one, y is less than or equal to x plus 3. That means there is no number there, so that's a 1 in front. So that means I have a slope of 1 over 1 and a y-intercept of 3. And so I'm going to have a solid line, and then it's less than, so I'm going to shade down. So I'll have a solid line starting at 3 with a positive slope of 1 over 1 shading down. Okay, so here I have it graphed and shaded. If you want to skip, the important part is where the shading overlaps, because see how the lines intersect? That might not necessarily be a solution, because see how one of the lines is dashed? So it won't be a solution to both of the lines, okay? The solution set for inequalities is where the shading overlaps. So maybe after you do your first one, where you see the second one shading, you might just want to shade this area, but since these are notes, I just went ahead and I shaded every area. But so far, this is the important area, this overlapping area. So we just need to graph the third line, and that one has a slope of 1 over 1 again, and then a y-intercept of negative 2, and I'm going to shade up, and it'll be a solid line because it was underlined. So I'll start at negative 2, go up 1 over 1 with a solid line shading up. Okay, so here I finished graphing it, and I shaded everything up, but again, that important area is, this is the shaded area, so it's bounded by where these 3 lines are, and that's where every single color is shading in, all right? So this final question is 1, 2, a solution. If it's in this common shaded area, it's going to be a solution. And if it lands on a solid line, it'll be a solution, but if it lands on a dashed line, it will not be a solution. So let's see here. 1, 2 is right here, so it's just outside the shaded area of all 3. So just because it's in 2 of them, it needs to be in all 3 of them. So the answer to this one is no, it is not a solution. Okay, so on example 2, I'd like for you all to do this kind of on your own, but um, I'll go ahead and I'll get you started with solving each of these for y. So the top equation, I have this 2x plus 3y is less than 6. I need everything to be y is less than or equal to whatever, in y equals form. So the only way to do that is by minusing 2x to the other side, and I'll continue my work right here. 3y is less than, and I'll put this negative 2x first and put plus 6. So that means I can just divide by 3 to everything, and it's a positive 3, so I'm not flipping my sign, so I get y is negative 2/3 x plus 2. Okay, so this line's ready to go. The second one, you have that negative, so it's not ready to go, but it's easy to remember. If you have a negative y, flip all the signs, including the inequality sign, and then it'll be ready to go. Okay, so that's going to give me negative 2/3 x plus 4, and now it's a greater than or equal to sign. And so this last one, I know I can add 2x to the other side, and so I'm going to get y is less than, and looks like it's going to say 2x minus 2, because I like to put the x part first. So graph these three yourself, and I'll graph it too, but I won't really explain it. And then check to see if negative 6, 0 is a solution. Okay, so you can see that I don't have any area here that overlaps with all three colors, and that's partially to blame because of you had these parallel lines. You had two lines with a slope of negative 2/3, but they were shading in opposite directions, and that's the important thing. If they were shading in the same direction, we would have a common shaded area, but they're not. So because of that, not all three colors overlap, and so the answer to is negative 6, 0 solution is once again a no. All right. What I like to do now is, how do you form a system of equations from just a graph? So the important thing to do is, it's like how I graphed it before. You have a y-intercept, you have you have a y-intercept, and you have a slope, okay? So in this graph, it might be a little hard to tell. This is the y-axis, and this is the x-axis, and the lines that are graphed are a little bit bolder. So that being said, let's look at this first line here. This first line is going straight up and down. So that's going to be an x equals line. I know it's going to be an x equals line because it passes through the x-axis. So I say x equals 1. But remember, these are all inequalities, so you're not going to have an equal sign. You need to pay attention to which way it's shading, and it's shading to the right of 1. So if you were to go to the right on a number line, you'd be increasing in numbers. So you'd say x is greater than 1, and because it's a solid line, you'd say greater than or equal to 1. All right? So the next line to cover is this dashed line that's going right here. So I know that's going to be a y equals 1, but it's going to go, let's see here, y equals 2, but the same thing as before. It's not going to be equals. So it's shading down. You see the area, the triangular area that's shaded in is underneath the line. So that means I'm going to say less than 2. And I won't underline it because it was a dashed line. So that covers 3 of them. I mean, that covers the first 2 lines. So now let's look at the third line. And that's this one right here. Okay? So the tricky thing about this one is my y-axis is right here. So we need to determine our y-intercept. So if you were to just continue the graph, you can kind of tell that it's going to intersect right there. So that's going to be your, plus or minus answer. So it looks like it's going to be at negative 1, 2, 3. So I'm going to write a negative 3 here. And then what's my slope pattern? what's it doing? It looks like it's going up 1 over 1, up 1 over 1, up 1 over 1. So I just have a 1x. So I have a 1 for my slope. So I can put a 1x minus 3 or just an x minus 3. And which way it's shading? It's shading on top. So if it's shading on top, that means it's going to be greater than. So I'm going to say y is greater than. And then it's going to be greater than or equal to. So y is greater than or equal to, because that line was solid. So y is greater than or equal to x minus 3. And now I have my system of inequalities. Notice how you didn't have any equal signs. Okay, so never have an equal sign when I'm asking you to write a system of linear inequalities. Okay. Now, example 4, without using a graph, is 4, 6 a solution to the inequalities? So without a graph, you just need to plug in your numbers. I have an x number, and I have a y number from the coordinates, so it's always x comma y. So all I'm going to do is I'm going to substitute 4 for x and 6 for y into these three equations, or inequalities rather. Okay, so what I've done here is I've substituted 4 and 6 into each inequality, and so the first one got me 4 minus 6 is greater than negative 3. So 4 minus 6 gets me negative 2. Is negative 2 greater than negative 3? Remember, if you have a smaller negative number, that is greater than it. So pretend you owe somebody $3. Now you owe somebody $2. Okay, so since I owe them less, I technically am, since I'm less in debt, I have more money, even though I don't have money. I don't know, it sounds confusing, but negative 1 is bigger than like negative 1,000, okay? So yes, this is true. Whoops. So I just check. They need to all three be true. If one of them's false, the answer is going to be no. So let's see here. I plugged in 4 and 6 again into the middle one. That got me negative 18 is less than 1. Negative 18 is less than 1, so that's also true. And then the last one, is 10 greater than or equal to 8? Yes, it is. So yes, this is a solution. Just to recap, if it got no on any one of the three, if it made a false statement, the answer would be no. So is it a solution? Yes, it is. Now, the last thing I wanted to go over was a linear inequality word problem. And these are real tricky. You have to really pay close attention to the language of them. But it says you can spend at most $60 on beads. So I'm just going to start my equation right here. At most 60 means you can be less than it or equal to 60. But you cannot exceed 60. So that's why I'm going to use a less than or equal to 60. A bag containing red beads costs $2 per bag, and a bag containing blue beads costs $3 per bag. So it looks like I have my two variables here. I have x is going to be the number of red beads. So let's just write x in red. And y would be the number of blue beads. I'll write that in blue. Okay, so I have my variables defined. Now let's finish reading the equation. The word problem, I mean. So it says you need more bags of blue beads than bags of red beads. You need a minimum of 4 red bags. All right, so minimum of 4 red bags means, let's see, red bags was x, wasn't it? So x is going to be greater than or equal to 4. Because I can have 4 bags at minimum, so 4 can be greater than or equal to 4. But I could also have 5, 6, 7, 8, 9, 10 bags, whatever. So there's that first one. And it also says you need more bags of blue beads than bags of red beads. So the blue beads needs to be more, so y needs to be more than the red beads. So y is going to be greater than x. That's all that one is. Okay? This last one, $2 per bag for red and $3 per bag for blue. So look, I can say 2x plus 3y is less than or equal to 60, okay? Because you can spend at most $60. So I can spend less than it, or I can spend exactly $60. Now, the last thing I want to do before I close out this video, I know I'm running just a little bit long, is I want to make sure everything's in y equals or x equals, so it's ready to graph, okay? So this equation right here, I need to make sure it's ready to graph, all right? So it needs to be in y equals. The only way to do that is by minusing 2x to the other side first. So you have 3y is less than or equal to negative 2x plus 60. Now I can divide by 3. And once I do that, that's going to give me a final answer of y is going to be less than or equal to negative 2/3 x plus 20. So since this is in y equals form, it's ready to graph. The other two are in y equals or x equals form. That's ready to graph and shade in. And, you'd have some sort of graph that would look similar to that. And you'd find your common solution set to see how many bags of red beads and blue beads you could buy. So that's it for the notes. Thanks for watching. Goodbye, everyone.